if you look at some of the inputs that we've discussed in previous episodes, nanoparticle fertilizers, micronized mineral powders, active microbials to fix NP and K or to do decomposition, et cetera, et cetera. This is what scientists are engineering in laboratories and crop input and manufacturing facilities around the world to essentially emulate what nature does on a macro scale and put it into usable opportunities that can be shipped around the country and implemented in various farm ecosystems. Now, sure, we can go out and build soil through the things that we can access in our local environment, compost and mulch and animals and so on and so forth. But at the end of the day, if you actually take a step back and look at America and the agricultural system we're in, we're extremely input heavy, right? And we're extremely reliant on soluble NP and K, pesticides, herbicides, and so on and so forth that have escalating costs that we've discussed in previous episodes like last week. And so when faced with a challenge of how do we maintain our current level of agricultural production and regenerate our land at the same time, it's going to take some significant intersection of science, technology, ethics, and machinery management, and so on and so forth to get there. But we're not going to get there if we don't have the proper insight about how soil is originally created, how it's developed, how it's maintained and implemented, and then begin to emulate nature's methods in our own shape, right, in our own universe. So when we talk about physical weathering, you might take a crop input such as lime, right, and you might, or soft rock phosphate, or a compost type material, and taking that particle that might be at whatever 500 microns in size, and shrinking it down through physical manufacturing versus physical weathering, so that when it goes out into the field, you get a much more rapid uptake. And so you're able to replenish and get rapid uptake of minerals that were depleted from soils over the course of the last 50 to 70 years through agricultural practices. And similarly, if you take some of the chemical methods that are currently used for extraction, obviously extraction of phosphate from phosphate minerals, or extraction of potassium, but in softer chemistry now, where they're using softer acids to release different types of minerals from rocks, basically, there's a little bit more retention of minerals and less harsh input on the soil environment that the minerals are applied to. And so what form does this take, right? So you have then a mineral powder or a mineral substance that may be coming from lime or something like that, but then it also goes through, once it goes through a physical mechanism of manufacturing, it would then go through a secondary chemical manufacturing step, and then maybe even in certain cases for certain manufacturers, a third step of biological weathering, right? And so manufacturers around the country and around the world are developing different inputs to emulate nature and use nature's processes in an intelligent way to provide deliverable nutrition in an organic and regenerative way. So a lot of the inputs that we sell on our website and through our wholesale sales channels have these techniques in mind. And it's really startling and innovative what folks have come up with in order to sort of emulate nature. But it's even more startling the plant response that you can get when utilized in coordination with proper analysis that actually drills down with insight. And so if you take a step back again and you look at the history of soil analysis, right? In our literature review, we've done multiple different stages to that. So one was we actually looked at where soil analysis came from, who has actually developed it, at what time in our evolutionary history it was developed, and so on and so forth. At the same time, we've looked at the current soil analysis methods and protocols and how they've been reviewed by a variety of scientists and a variety of different soil types across the world. And what we found was that the original soil testing labs were oftentimes regional labs that were developed and started out through university scientists. Later on, that expanded to regional extension type services that supported public testing of samples. And after a little while in that, the land grant universities and private businesses started a public-private partnerships where the extension service would partner with a local laboratory or maybe a local extension agents, stopped working for extension and started working for a independent laboratory or spun out an independent laboratory to, essentially analyze soils in a particular region. And that back and forth actually did quite well for a while. As commercial fertilizers became available in the 1950s and 1960s, the soil testing system was refined to pair with the crop management systems and protocols that were being implemented with commercial and conventional fertilizers. So essentially, what the current methods that are utilized in laboratory analysis methods, broadly speaking, today are utilized from the basic analysis methods that were built off of the original interaction between soluble chemistry and higher levels of organic matter in soils. And so that system being developed in the 19 originally in the 1950s, 40s and 50s, and later expanded and professionalized in the 60s and 70s. And so if you actually go all the way back and you start to look at 1839 when phosphorus was identified as an essential plant nutrient, right? Or potassium was identified in 1856. Some really we didn't even have a pH scale until almost 1910, right? So if you go all the way through into 1929, that's where the field test for available phosphate was developed, was for 1929. And so that's quite a while ago, right? And over time there's been some modification to that, but ultimately it's relatively unchanged from that. And as you go through all the way up to 1930 was the first time we actually had pH meters and glass electrodes. And 1953 the Mehlich abstractions began. Mehlich first started with Mehlich 1, later expanded to Mehlich 2, and in the 1980s Mehlich 3 was released, which is what a lot of folks still utilize today as a cross soil type analysis method. Once we hit the end of the 1990s and into the early 2000s, something started to shift within the marketplace where growers started to look more deeply for different methods that were a little bit more focused on soil health outcomes. And that has led to the last 20 years with the advent of the Haney test, a lot of the work that we've done internally, a wide variety of water-based extraction methods, including saturated paste and others. And a lot of these have attempted to replicate plant analysis uptake and plant response as a revival of that original pairing of plant response with soil analysis methods. I'd be remiss if I didn't mention Dr. William Albrecht in this timeline, because his analysis methods and protocols in the mid-1950s, essentially developed the original base saturation and the base saturation scale and base saturation percentages that are often used in most labs today. Carbon is king. Thanks again very much, and look forward to seeing you all next week. Take care.